Hello, I'm Carlo from the Emona Instruments, and we are here with the National Instruments learning platform, the ADS Max. We've been partners with NI since 2009, providing top boards for their academic learning platform. Here we have the Controls Explorer board plugged into the ADS Max. So this board has a number of blocks which are planned. And what we do is we have the students investigate the step response and the system response of the plant. But one of the most exciting experiments that we get the students to do is a PID controller. Now, there's a lot of maths associated with PID, but if a student can actually build a PID controller and manually adjust the values, they can intuitively understand what that mathematics represents. So here, for example, I've wired up a signal, a random signal, which I've created, a custom waveform. I'm bringing it into my PID control loop. It has a number of plant, first and second order RLC plant, and as well, there's a breakout board for doing your own thing. What we do as well is we build a PID controller as separate blocks. We take our input signal from the function generator and bring it into the PID. Now notice here we have a difference block, and then the student patches the difference block, the error signal, to the PID. Then the PID has 3 different branches, and the student can adjust the proportional branch, and then they can investigate the signals, and then we can introduce the integral branch by switching it in physically. We switch in the integral branch, then the student can adjust the integration rate, and as well we can introduce the differential branch by simply switching it in. So we're literally giving the students an intuitive, hands-on experience of a PID controller and its response to various plant. And then I have control over each one of the 3 branches. If we have a look here, we can see numerous signals at the same time. Here is the input signal, which comes from the waveform. It's just a random custom signal brought in. And the green signal is the output of the plant, tracking the waveform. Here is the proportional value, which we can view. And the brown one is the error signal, which is the difference between the orange and the green signal. You can actually see it and see that it's mathematically correct. Now, if we switch in the integral, notice now that the signal is overshooting, and we can make adjustments which changes the period or increases the period of the overshoot. And naturally, we can stop the waveform for closer inspection. Then they can take measurements of the values they've set up and compare it with the mathematics. So what we're about at Emona is making the mathematics come alive for the student with experiential, hands-on experiences. So we have our 4 boards for the ADS Max learning platform. The first board, the most popular one, is the Datex telecommunications board, which is a series of blocks that the students patch together to build up to 22 different telecommunications experiments. It's an entire 2-year course in one board. The second board of great interest is our Signals and Systems board, the ESSB. Once again, a block diagram approach to teaching signals and systems, and it's accompanied by a manual which covers the entire Signals and Systems course. So students can get hands-on learning as to what the mathematics means. Rather than just do math and then forget what it means, they have an experiential lab experience with a board. The third board is our fibre optics board, the CONTEx. It gives electrical engineering students a safe, low-cost experience with fibre optics principles like wave division multiplexing and bidirectional communications without having to go into the expensive laser-based labs if they're not specialists. And finally, a new board that we're announcing today is the CONTEx, the Controls Explorer board. This board is aimed at giving electrical engineers a quick exposure to controls theory, which may not be their number 1 topic.